Okay, so today we're going to dive into the world of Mathematics 11, Principles of Mathematics 11. So I'm assuming that everyone has done Mathematics 10 before and everyone's comfortable with it, and we will start off with systems of equations. So we're going to solve system of equations by elimination and substitution. However, there's also a method using graphs, but since it's hard to do graphs on the whiteboard here, that's going to be some other time with technology. So recall that when you're working with any equation, such as the first one, whatever you do to one side, you have to do to the other. So for example, if I divided the left side by 3, I would have to divide the right side by 3. Also recall that if you're adding or subtracting, the operation that you do to one side, you have to do to the other. It's the opposite. So for example, if I have 3x here, it would become negative 3x on the other side due to the subtraction from both sides, and therefore the two rules build on top of one another. So, to solve equations, we can add another rule to the equations. You can add or subtract the two equations to form a third one. So with this conveniently placed example, we can add the two equations to make a new equation. Now you can see that 5y minus 5y would be 0, and it would cancel out. 3x plus 4x would be 7x. And 4 plus 3 would be 7. X equal to 1 as we divide 7 by 7 to get 1. Now, this is one of the more advanced examples since it will require you to manipulate some of the things. Now, what is something that you see in the first and second thing that we can find a multiple of to be equal? If we multiply this second portion, or if we multiply this monomial by 2, then we will have 4y like above. However, if we want to have this to be 4y, we need to multiply the whole equation by 2. And now, since we have something canceling out, we can add them. Sorry, in this case we can subtract them. So, at the moment, we have 3x minus 8x. 4y minus 4y, and 3 minus 6. And now we can solve for x. And now that we have x, we can plug it back into the equation and get y. Now, the method of substitution can be useful when you have a system of equations in which one of the equations is simpler to manipulate than the other. However, you will have the choice of using the graphical method, the choice of using elimination, or the choice of using the substitution, whichever throughout, whenever you're doing any system of equations, and whichever one seems to get you the answer in the simplest form is the one that I advise you to choose. So for example, in the system of equations such as so, we can see that it's obviously easier to manipulate the second equation than the first one. And rather than having to multiply this one by 3 or this one by 4 to have a monomial cancel out, we can substitute one into the other. By isolating one of the variables in the second equation, we can substitute it into the other one. So for example, I chose to isolate x, but it works just as well if you isolate y. Now, since these x's and these y's are the exact same, therefore they're a system of equation, we can substitute this x for that x. And now that you have y, you can easily substitute it into this equation, or that equation, to find out x.